All right, guys, good afternoon. We're going to talk about mixed factoring today. We've learned about GCF factoring, we've learned about trinomial factoring, but up to this point, it's been really clear and direct. I would tell you which method to use, and each problem would be ready to go that way. Now I'm just going to give you sets of factoring problems, and you need to learn to decide which route I should go and how I work them out, and then to go from factoring to solving, okay, which we've already started. We're just going to continue that. All right, methods of factoring we've learned so far. You guys already know these. Okay, so if we look at GCF, that's the greatest common factor. So we're looking for what factors we can pull out of both terms. So in terms of the 8 and the 4 here, if we need to, remember, you can go back to factoring each of them. 2, 4, and of course the 4 itself is one of the factors in the 8. So we can think of just pulling out that 4. Now, if you can see that, you don't have to use those factor trees, but that's where we want to head. So we pulled a 4 out of both of them. What's left after the 4 is just the 2. That's all that's left out of the 8. So once we pull the 4 out of the 8, the 2 is left over. And once we take the 4 out, 4 divided by 4 leaves that 1. We're going to leave it there for a placeholder. Now, in the past, I told you for the signs, we would just copy them right into the original terms that are now in the parentheses. But if you want, and in this case, I would encourage you, you can now also pull that negative out. I feel like we've got the GCF method well enough that we're going to start pulling out the signs with them. Since both of those original terms are negative, you can also pull out the negative from both terms as well. So in addition to the 4, we can also pull the negative out in front of it, which means both of these become positive, okay? Now, if you didn't do that, it's not going to be incorrect. You actually have the choice of leaving the negative inside on both terms or factoring out the negative to put it on front. They're both correct. I would give you the points on a quiz either way. Okay, I just want you to understand you can go either way with that. And then we continue with our variable x's. The x squared has 2. There's only that 1x there. So again, we would just take an x off of each of those. And that leaves only 1x on the front term, nothing left in the back. And there you go. That one's done. That's our GCF method. We pulled out a 4x. And in this case, I also pulled out the negative, or you could leave the negative inside on both terms. Either way works. Okay, trinomial, I feel like you guys are getting pretty good with that. What adds to the negative 7 multiplies to the 10. I'm going to guess it's a 2 and a 5. And since they both have to become negatives, and they'll be the same sign since they multiply to positive 10, they must both be negatives. There you go. Okay, so there's our review of those methods. Now, what if it's just a mixed set of problems like we have in front of us? How do you know what method or route to go to? Great question. Okay, to start, it's really a pretty easy answer. We'll always, always, always look for a GCF, okay, to start with. So first, always look for a GCF. If there's one there, you want to use it. So I would look here at this example problem number 1, right over here. And that is, it's only got 2 terms. So the methods we know, the GCF and trinomial, this one obviously can't be trinomial because there's not 3 terms in it. So it's going to be a GCF. And out of that 12 and 8, I'm going to think of pulling out a 4. So if I pull a 4 out of the 12, what remains is a 3. If I divide a 4 out of the 8, what remains is a 2. And again, if it helps you, by all means, use your factor trees to break those down. There's that common 4 I pulled out. Now again, the signs, since they're both negative, I'm going to pull the sign off of both. Okay, and if both of them had a negative pulled out to the front, they're now both positive. So I've got a 3 in the front and then plus 2 for the second term. I pulled the negative out. The x's, same idea. If I have 2 x's and then 1, pulling 1x out leaves just 1x on that front term that was an x squared, and the second term doesn't have any x's left. So we're done, okay? Now, if GCF is not a method I could use, let's continue. Let's look at, or rather, let's look at, yeah, we'll go to number 2. This one down here. Hopefully that one obviously is trinomial method. You're starting to just see what they look like. They always have an x squared up front, and then some x term and some constant. So if I tried to GCF this guy, it's got to be something in all 3, and there's nothing that's there. There is no common term. The x is missing from this back guy, and there's no coefficient, no number on the front with the x squared, just a 1. You can't pull a 1 out. That's not a valid factor. So there's nothing common to all 3 terms, so GCF didn't work. What do we go to after GCF? We then check to see if it is something we can factor with trinomial method. And hopefully you can come across these and see them obviously. Number 2 is obviously that. So I would immediately just go to that method. And again, my 11, if I look for a factor tree here, I'm going to try 1 and 11. Those are the only factors there are, so hopefully they work. And since they multiply to a negative, I have to have mixed signs on the answer. And since they add to a negative number, the 11 must be the negative, the 1 is the positive. And so there we go. It worked out to go trinomial method. Now, what happens if we look at number 3? It looks like an obvious trinomial type. We're used to seeing that, but there's something important you need to notice. There's a negative in front of that x squared, which means this isn't the simple trinomial type we've learned so far. All of the simple trinomial types we've learned, if you go back to number 2, always, 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 there's nothing in front of that x squared, okay? So the invisible coefficient there is just that positive 1, okay? It's a 1 and it's positive. That's what we have on our normal trinomial, so this one's not that. This is a negative, which is a problem. You can't use the normal trinomial method. So we go with our normal progression here. We always want to look for a GCF and then go to trinomial. So if there's a sign out there that you don't want that negative on the x squared, well, we know how to fix that. We can, just like we did on problem number 1 here a minute ago, we factored out the sign to the front of the problem. We can factor out the sign. So if I just want that negative on the x squared to go away, I could just factor out a negative 1. If you want to think of it as a negative 1, go ahead. If you want to think of it as just taking out the sign, it's just like a distributing in reverse. So the x squared flips, or the negative x squared flips and becomes positive x squared. Plus 6x becomes minus 6x. Plus 16 becomes minus 16. And notice this is just like if you were to distribute back the other way, okay? You'd multiply that negative 1 through. It just flips all the signs of each term in that trinomial. We're just doing that in reverse, okay? So each of the signs flips, and you're always allowed to do this. You're always allowed to pull out a sign from each of the terms. They don't have to all be negatives. You can start with, you're always allowed to pull this out and then just flip the sign of each term in the parentheses. You're just creating that reverse distributing problem by factoring out the negative. You're always allowed to do that. And in this case, the reason we would want to is because now we just created a trinomial that we can factor. So number 3 is actually both methods. First, I GCF'd out the negative. Now, I can apply my normal trinomial skill that I know how to do and finish factoring this one down. So 16, I think of some factors. I notice they're going to add to 6 or possibly subtract to make a 6. So I'm thinking in my head a 2 and an 8 would be a good start. Okay, and since it's multiplying to a negative 16, I know that the signs need to be opposite. So I'm going to fill in my normal x here, and I know my signs need to be opposite. And since it adds in the end to a negative 6, I know the bigger number 8 needs to be the negative. And so there we go. Turns out GCF and then trinomial factoring, we're able to break this guy down. Now, don't forget, we factored out that -1 on the front, he needs to be part of the factored answer. And you just leave him right up there on the front. So this is your first example of putting both methods together. We used GCF to get the negative out, and then we just used our trinomial factoring and broke it down the normal way. Okay, so there you go, they're together. Now let's look at the fourth example. Again, we'll start with GCF and we'll look for something common. So I can look for a variable in each, but there is no x. I shouldn't use an x to say there's no x. There's no x in that last term, so I can't pull out any x. So then I can look for the coefficients. 5, a 3, and an 8. There's no common value I can divide out of a 5, 3, 8. So this tells me I cannot use a GCF. Okay, it won't work. And as far as trinomial goes, you guys have not yet learned how to trinomial factor if there's something on front. I couldn't use GCF to get that 5 out of there. So it's not factorable by GCF or trinomial methods you guys use. So on problems like this, we're stuck. And there are problems like that. There are problems that are unfactorable or at least not factorable by normal methods. Now, it'd be good to have a way to factor this, a go-to method. Thank goodness there is one. You guys might be familiar with it. It's called the quadratic formula, and that's what we're going to learn next lesson. So when you're trying to factor, if your GCF and your trinomial methods don't work, we'll have a go-to, and that's the quadratic formula. All right. This last one here is number 5. It's just one more example to help you guys walk through the mix of doing both. So when I start a problem, I'm going to look for GCF. Okay, I see 3 terms, so I immediately think maybe this is a trinomial type. But the fact that I have something up front tells me unless I can GCF factor out that front value, then I can't use trinomial. So right now the question is, can we factor out the 2? Because if you can factor out the 2, then it'll just become x squared, and you'll be able to work that with maybe your regular trinomial method. So let's try it. So if I divide a 2 out, these two have to be able to divide a 2 as well. And they're both even. 18 and 40 can be divided by 2, so it looks like it'll work. So I'm going to GCF factor out a 2 from that, just leaving the x squared. And again, factorial tree, by all means, if that helps, use a factor tree. And if I write them both as factors with 2, I can see once I take a 2 out, there's a 9 left on the middle term, and there's a 20 left on the last term. So I've just taken a 2 out of all 3 terms. And then for now, well, actually I can look and see for variables. I've got x squared x, but no x's on the back. So I can't take any of my x's out. I'll just leave them, which is okay. Copy down the signs. And there we go. I basically just factored that 2 out. And now it looks like my normal trinomials look. I bet I can trinomial factor that. Bring down those x's, and then just break down my 20. Since it's a positive 20, I know the signs will be the same, which means I'm looking for 2 numbers that are going to add to -9. I bet 5 and 4 are what I'm looking for. Have to have the same signs. They have to add to a -9. So there we go. -4, -5. And one more time, don't forget, we pulled a 2 out as the GCF. He can't just disappear. So this is my factored form. First, pull out the GCF. If you have one, look for a GCF. Okay, and remember, that can include just a negative. It might just be a negative on the front of the x squared that you can GCF out. And then 2, try your trinomial method. if it's got 3 terms. If it looks like it's a trinomial you could factor, pull out a GCF, and then see if trinomial works. All right, let's try these together and see if we can walk through them, okay? First, GCF, and then second, we can try trinomial. So the first one, I would say pretty obviously is GCF, yeah? It's only got 2 terms, so it's certainly not trinomial. That's all we've got to do that type is GCF. Okay, this one's only got 2 terms. So I'd say that's pretty obvious. It's got to be GCF. I look at this one and see that, yes, he's got 3 terms. He might be trinomial, but there's something on the front. So if that one's going to work, I'd have to pull a GCF out first. So I'm going to try in GCF and see if that works, and then do trinomial after that. And see if I can get that to work. Okay, that same exact idea is also true over here. I've got a trinomial, but there's something up front. So first, I've got to try GCF to get rid of that 3, see if I can factor out a 3, and see if I can use trinomial factoring for the rest. This last one is already a trinomial with nothing up front. So I think it's ready for direct trinomial factoring right now. It's already ready to go. All right, pause it and see what progress you can make on those, and then I'll come back through and solve them for you. Go. Okay, if you're back, I'm going to look at this first one. I'll put it right here. And since they're both negatives, I'm going to factor out the negative from the inside. And a 9 and a 6, I can take a 3 out of both. So I'm going to take out a 3, which leaves a 3 in the original 9. And out of the 6, factoring out a 3 leaves a 2. And since the negative was factored out, they're now both positive, because I took out both of their negatives. And as far as x's go, I can take 1x, because they both had an x to give, and there's 1x left from the x squared in the first term, and there we go, negative 3x times a 3x plus 2. Okay. One over here to the right, I want to try and get a 3 factored out. If this is going to work, I've got to be able to take a 3 out, and then I can try my trinomial method. And notice, guys, I just jumped right to trying a 3, because the only way this will work for us is if a 3 comes out. If a 3 doesn't come out, we can't finish factoring it anyway. So I'm going to try a 3 and just see what happens. 6 divided by 3, yeah, that works. That leaves 2. I'm just copying down as x. And then the 45 divided by 3, yep, that works too. That leaves 15. I'm just copying down the signs. So now it worked to do that first step. Gotta love this dry erase program sometimes. I want to get a little more space. I'll just copy this down. All right, so we were able to factor out that 3. So now we'll just finish it and see if trinomial can also make it work. And did anybody notice I have a 3 there? That should have been a 2. I must have been talking about 3s when I wrote. Okay, let's see, 15, I bet it's 3 and 5, just off the top of my head. They have to multiply to a negative, so then they have mixed signs, and we're adding them to a positive number, which means the bigger of the 2, the 5, must also be positive. There we go. Don't forget, we GCF'd a 3 off the front, so using both methods, we were able to factor that guy all the way out. All right, this one over here, same exact idea. I'd have to be able to pull a 6 out to make this work. But as soon as I look, 5 does not have 6 as a factor. I can't divide a 6 out of 5, which tells me we can't factor this one. If we're going to factor it, we're going to need to use the quadratic formula, which we are going to learn starting tomorrow. Okay, and then these last couple, GCF down here, I'm going to pull an x out, and I'm going to pull a negative out, since they both have a negative and they both have an x. So his sign switches, and one x has been taken. So all that's left in the front term is an x. The second term, his sign was taken, so it's now positive, and an x was taken. So all we have left is 4. There you go. Last one is already ready to go. I can jump right to trinomial. Either 1 and 9 or 3 and 3. Mixed signs, since they multiply to a negative. So they're going to subtract to make an 8. That means it's 1 and 9. The answer was negative when they add, so the 9 needs to be the negative. And there you go on that guy. Okay, hopefully this is making sense to you. All right, I was thinking of going further, but I think I'm going to stop there and let you guys practice and get this stuff down for today. So there's a set of problems for you. Work through them. I'm not going to indicate which method or how. These are all for you to figure out. But you can pause it, do the work, and then I will create the set of solutions for these afterwards so you can see how you were doing. Go. All right, I'm just going to jump through these at a quicker speed. I'm looking to factor this. I bet it's 8 and 7. I know I can go straight to trinomial method because there's nothing up front. I don't need to GCF anything out. I can go right to factoring with trinomial. And 8 and 7, if they're going to subtract to make -1, the 8 needs to be -7 positive. All right, next one down. There's only 2 terms, so I'm going to factor out the negative on that, and I'm going to factor out an x using the GCF method. So all that's left of there is an x on the front term and a +6 on the second term. Okay, third one. The important thing to notice there is that negative. I need to pull that out so that it becomes just a regular trinomial with a +1 on the front of the x squared, and then we'll see if we can factor what's left. So if I pull the negative out, all the signs get flipped. So now from here, I'll try my normal trinomial method and see. Let's see, 42, 6, and 7 come to mind. Whoop, that was easy. 6 plus 7 makes 13. And don't forget, that was a -1 you pulled out. You need that on the front. So there's the fully factored form of that quadratic. Okay, up here. In order to use trinomial, I would have to be able to take a 4 out. And yes, I can take a 4 out of that last term, but GCF means everybody has to be able to give it, including that 3. And 3, you can't divide a 4 out of a 3. So we can't factor that one. We would need to use the quadratic formula because we don't have the methods yet to do that. Okay, last, trinomial with something out front. I'm going to try and factor that -3 off and see what happens. Now, since the x squared and x are only in the front 2 terms, there's no x in the back, I know the x squared and the x have to stay. So I'm just going to leave those and just focus on the coefficients. So if I divide out the -3, let's see if I can take a 3 out of a 24. I can. Can I take a 3 out of a 36? Yep, I can. Good, it'll work. And remember, I pulled a negative out with it because I need that x squared to be a positive x squared in order to do my trinomial, which means all these signs will flip. If you pull a negative out, it flips all your signs. So I'm going to have a negative, and then the 8 is left out of the 24. Now I'm going to have a positive, and the 12 is left out of the 36. Okay. And don't forget, you can always double check. If you just go back the other way and do your distributing, you can make sure and see, did I get everything right? It should all turn back into the original problem, which it would. We're good to go. So now we just finish with our trinomial method. Let's see, 2 and 6. I see an 8 that they add to, so I'm guessing 2 and 6 that are the same sign, so there you go. It's an x minus 2 and an x minus 6. And I knew you already remembered that -3 up front. there you go. There's your final factored quadratic equation. Good job, guys. Later.